Hello folks, so in this video we are going to talk about using the generic rectangles to divide polynomials and what happens when there's a remainder, because this one will have a remainder. It's a little awkward, but it's really not too bad. It's just one more step on top of what we're already doing. Alright, so once again, I have now a cubic divided by a linear binomial. So I always put the divisor on the left side here, and the dividend, the thing that's being divided, slightly staggered underneath here, plus 2x minus 3. And again, we're trying to fill in the rectangles here. So again, we know what the sum of all these rectangles is going to be. The sum of all these rectangles has to add up to this. The question is just, how does it get broken up? Okay, and we know, remember, we know that there are going to be at least 3 here, because to get from a cubic to a down to a linear, we need to go through x squared, x, and then a constant piece. Okay, so question, how many times does x go into x cubed? Well, I think that's going to have to be times x squared. So I'm going to fill this in. X times x squared is going to be x cubed, so we've taken care of that x cubed, so that's good. And let's see what's left over. I have to do, again, that plus 2 is always just along for the ride. So 2 times x squared, it's got to have to be 2x squared. Okay, well, remember, my x squared terms are always going to be diagonal to each other. All my like terms are going to be diagonal. And so I have 2x squared, and I'm trying to get to negative 4x squared. So I'm going to need negative 6 more. So it's going to be negative 6x squared, and so now I'm good on my x squareds. The question is, what do I need to multiply x by to get there? Well, let's see, that'd be x times negative 6x will give me this negative 6x squared. So again, that plus 2 is just along for the ride. 2 times negative 6 be negative 12x. Okay, now once again, we have negative 12x, but we want, let's see how much we want. We want 2x, so we're going to need plus 14 more. So we're going to fill it in with 14x. Sorry, this should be in blue here. Negative 12x. This is going to be 14x, because we need x times 14 gets us to 14x. And the last part, this is where it's going to get a little awkward. So again, the plus 2 is just along for the ride. 14 times 2 is 28. Question, not question, but problem, because we're supposed to end up with negative 3, but we don't. But we can carry through the idea of the like terms, again, being diagonal. So the x squareds are all right there. All the x cubes are right there. All the constant terms then would just be right here. And we're just going to have to fill this in right here. And so what's going to happen is we're going to have to fill in another box right here and say, okay, well, I have 28 and I need to get to 3, negative 3. So how much more do I need? I'm going to need 31 of them, or negative 31, excuse me. So that's what's going to be in there. That is your remainder. That's our remainder right there. Okay, and we're just going to stop there, just like you would normally. And so the answer to this division problem up here is going to be x squared minus 6x plus 14 plus negative 31 over, again, over our divisor, x plus 2. Okay, now this might look a little bit awkward, and it kind of is, but I did this one with long division on the side here, so let me just pull that up for you. Okay, so here's the same problem done with long division on the side here, and you can see actually a lot of the pieces that you see within the generic rectangle actually show up in this part as well. For example, you see the 2x squared and the negative 6 right here. And you also see the 14x and the negative 12x right here. So these are actually, and the same process, they're just looking at it differently. So you might be thinking about, like, shouldn't there be something here to represent this part? And you're right, and we could go about it right there. I kind of tried to hand wave it, but then I realized that's not quite fair to you. So the question still is, what x plus 2, I'll fill this in right here, in red here. X plus 2 times question mark gets us to negative 31. And we don't want to add too many things here, because if we keep doing that, we'll just be stuck forever. But the answer to this question, the question mark, is equal to, well, you just divide both sides by x plus 2. And so this really should just be, which is the remainder, plus negative 31 over x plus 2. And that's where this piece comes from. Okay, so again, a little awkward. When there's a remainder, it is awkward, but I think it's just a nice way to, it's nice to have options. So if you want to use long division, use long division. If you want to use the generic rectangle, use the generic rectangle. Hopefully this helps, and hopefully you feel pretty confident now about dividing polynomials. Now, dividing polynomials, we so far have been dividing them by, again, linear binomials, but there's no reason you couldn't use a similar process to divide a cubic by a quadratic or something like that. Okay, it does run into problems when the divisor is higher degree than the dividend, but we won't talk about that, at least not yet. All right, so thanks for watching. Hopefully this helped, and I'll see you in the next video.